DNA replication. In practice, it's pretty complicated, but I'm going to break it down like an enzyme for you today. DNA is the most complicated code in the entire universe, but it's only made up of 4 nucleotides, 4 monomers, and those nucleotides are adenine, guanine, cytosine, and thymine. Adenine and guanine are purines, cytosine and thymine are pyrimidines. A purine will always be paired with a pyrimidine, and that means adenine will always be paired with thymine, and cytosine will always be paired with guanine. It can't be any other way. Our nucleotides share the same basic structure: a phosphate group, a sugar, and the nitrogenous base. The sugar will always be deoxyribose because we're dealing with DNA. The nitrogenous base is where the nucleotide in question is determined. This structure will determine if it's adenine, guanine, cytosine, or thymine. So the first step to DNA replication is unwinding the DNA. It sits in a double helix structure, which is not optimal for DNA replication. So it flattens out, unwinds, and becomes kind of like a ladder. And this makes it possible for the H bonds, which lie in between the nucleotides, to be broken. They're broken with DNA helicase. DNA helicase unzips the genes, just like any teenage boy. That's its job, that's what it wants to do. That's what it has to do. So it'll unzip between each of the pairs. This makes it possible for DNA polymerase to come in and build and add complementary strands and add a complementary strand to the template. And then this will build successfully from 5' to 3', and this is a leading strand. However, there's a lagging strand, and the way the helicase unzips the DNA, it comes in and it has to build them in fragments because it's building from 5' to 3', but it has to keep coming in after it's done building a fragment. And once the DNA is unzipped to where it's needed, a primer will come in and seal the DNA, and that'll make 2 identical DNA strands.